Okay, everyone, here we go with another example problem. So we have a brass rod and it's stress-free at room temperature. Thank goodness. But it's heated up, but prevented from lengthening. Oh no, something's in its way. It says at what temperature does the stress reach 172 megapascals? The reason it's negative is because compression is always considered negative, and it's trying to get longer, but it can't, and so the wall is more or less compressing it. That's why it's negative. Okay, so originally it's this length. Afterwards, it stretches in length, or at least it tries to. This is what we're usually thinking about when we're talking about thermal expansion. Yes, it is not allowed to move beyond this point, but we imagine for just a minute that it was able to stretch, that it was able to stretch as much as it wants, and it gets this change in length. However, then we have to bring it back to reality and say, well, then the wall is compressing it back into its place. The wall is compressing it back in place. So the strain from compression is going to be equal to negative my thermal strain. Thermal strain was trying to expand. The compressive strain is trying to bring it back down. So we can then calculate our thermal stress by saying, okay, that's going to be equal to my compressive strain from the walls pressing in times the modulus elasticity. And if we want to, we can then plug all that in there. So it's going to be equal to the modulus elasticity of the material times its linear coefficient of thermal expansion times whatever the change in temperature is. So we can then rearrange and solve to determine when it's going to feel 172 megapascals. So in this case, once it gets to 106 degrees Celsius from 20 degrees Celsius, it will feel 172 megapascals, okay? 172 megapascals. And that won't be necessarily enough to make it fail in many cases, but in some cases it might, depending on what it is. Also, things typically fail later in compression than they do in tension. Not always, it depends on the situation, but it takes a lot more in compression than tension to cause things to fail. Okay, I know there was a whole lot of shenanigans in this, and I would suggest that you walk through the algebra on a sheet of paper just to make sure that you figure out where each step is going. And when you have an equation like this that's already solved for you, this is a good one to write down because a lot of your homework problems might pull this in and be asking questions similar to it. Just reshufflings of these variables. Well, have a good day. I'll see you all next time. Bye-bye.